In this video, in this lab, we will do video analysis of motions. And you are going to take videos of moving object and load video into a video analysis software called Logger Pro. And then you use the software to slow analyze to play the video in slow motion at the same time, analyze the object's motion. You download the software, follow this link. This software is very powerful and very interesting, and actually it's very popular in the universities. But it's expensive, but for you, it's free. And we just download the demo version. It worked for 30 days to let us to evaluate, see if we want to purchase it. But whether you want to purchase it or not, and we can use this for this lab. So once again, you download this. Suppose you have downloaded, you will see a Logger Pro 3.16 demo version here, and you just go ahead and start. I will show you the simple step, and suppose you simple step, and then suppose you will have, then it will look like this. Okay, and it can do a lot of things. If this software is for the computer to connect to a device like a pressure gauge, thermometers, motion detectors, and ultrasound devices, and then the data is transferred to the computer. You can use this software to analyze. But this time, we just use it to analyze the videos. So what do? If you take videos and you go here, insert movies. So I have find out where your movie file is. In my case, I have stored my movie file in this folder. Of course, I want you to take video. The first video you do is the cars. So I stored in this LAB05. Let's just reload this one for the, let's see, for the cars. And so just wait for a second, and you will see the video is loaded into this Logger Pro software. I don't know why it takes so long. Let me just pause it instead of using the time. Okay, now you see the video is loaded. In fact, it is the same video I took many years ago. So now you can first play this video once. Okay, it's like a car on the road. But now you can play it in slow motion to analyze. You have a lot of tools here. Okay, and then what do? You will stop the video, and then on this corner here, there are some tools for analyze video. Click down here, and in the lab report and lab, I write out the detailed step by step what you do. But here, just give you some quick guide how you can use this. So the car go from this tree to this tree. So then first this button is the coordinate, set origin. So you put here and watch. Here you go, the coordinate axis. Here is 0, and then you have some reference. You set a ruler, so it tell the computer from this tree to this tree is how far, which I happen to measure is 13 meters. But in your case, you have to go downstairs or go to somewhere to. So from here to here, see this green line is to give it scale. So it will say how from here to here, I will tell the computer it is 13 meters. So it would know what's in your case. Once that is done, and then the beauty of this system is you have this pointer, this cross. Every time you cross this, the video play one frame. You know, the movie was made by a bunch of pictures. Each picture is one frame. Every time you play one picture. So, but since the movie is nothing but a series of pictures that play continuously. So you take this, and then cards. Every time you click once, and the movie will go advance one frame, but then the object may move one step, At the same time, this cross will put the dots where it is. You see right here? But you don't want to do that, but I just show you. You can see, boom, there's a blue dot there. But actually, you put a blue dot where the car is. Okay? So then click a few seconds. So then you fast advance the car to some location. Stop. So see there's object. You click where that car is. Blue dots. So now I've seen same time it record the location, x velocity and z, and at this 1.5 seconds from the beginning of the video, the object is x 4.5. How does it know it is 4.5? Because I told the system here is my 0 and this distance is 13, therefore the car is 4.5 from here. Then every time that you just use this cross to mark where the object of interest is. So mark, you see these blue dots, but this video is not perfect for this purpose because there are trees in there. You hit the car's nose. Okay, so you see the blue lines, that's where the trajectory or the path the car goes. The car coming out. See there? The car coming out. So you put blue line. So then you actually you're supposed to hit the beginning of the car. So of course, as the car goes, the movie plays, the blue dots go further and further to the right. So, but this is not a perfect example. Okay, now I just do this. Once you're done, you put this, go back to the cursor. So you're done. So then at the same time, it's recorded all the time and the X location. Of course, you can record the Y location as well. We will use this to understand, to learn the circular motion, a projectile, any motion like a bird, how does it fly? And this is actually a real tool. And here it has all this location recorded down here. Velocity already calculated. So now you can do the analyze. We will talk more in the lab, but this is just give you some idea what this can do. So then go down here, you can insert a graph, which means you plot x and y, but y is not very interesting because the car is not jumping up and down. Simply see the y stay at 0, that 0 line. But then you want option, you want axis option to be the y-axis, so they will call it, okay, position in x direction. You type in there, you choose x. You can choose many of the things, and of course x-axis is nothing but time. And you done, you plot this, you see it's like straight line over here, and then you can, of course, if you finish the whole film, it will cross the whole coordinate frame. But we just did a little bit. In fact, from here to here is a straight line. Okay, and but then you can do analysis. Okay, and actually you can, oh yeah, y, you only plot y, let's remove that. You can remove y. Okay, you uncheck the y velocity, there's only one plotted, so there will be only one. So, which means 1 second, 3 seconds. So that's basically a straight line. You plot the x position and time. So what do? You can just fit it with a straight line. So this is basically a straight line. You do the click here. It's called a curve fit. And here, I think you are familiar with this. This is nothing but a linear equation. The m here is the slope, and t here is the independent variable, and b is y-intercept, which means you do try-fit. You try-fit it, which means you try to find a straight line that pass these data as good as possible, okay? And try to fit this line. So you say try it, so it's fitted, so there's a line, but of course I sort of jumped. But basically, so okay, that's the best line to fit the straight line. See that line there? I think in the video may not be clear, but it is. the straight line that go through this direction. And that's the equation. And then here you actually get to the parameters. The slope is actually the velocity. Okay, we will talk about in the class. So its velocity is 5.4 meter per second. Is roughly 5.1. So then, so it's good. In fact, calculate all these. It's called a linear fit video analysis. You get an equation of motion and y-intercept and so on. So this is just a glimpse of this tool. This tool is very powerful. It can analyze all different equations, but we just look at uniform motion. Okay, and you can imagine if you are doing sports and you can analyze wrestlers' motion, basketball player, soccer player. You can look at how they are moving by taking videos and slow down, watch the slow motion, and do the calculation. All right, just this much. We will do more after you install this on your computer and take a video of the car moving, and then we will load your video into the software and do a lab. Basically, calculate some velocities and do a graph and compare the result from this software to your hand calculation in previous lab. Well, let's stop for now. Thank you very much. Bye bye.